Hey folks, it is Thursday, January 22nd. We are here chatting about SIG Autoscaling and Carpenter's DRA effort. Jason was just talking about DRA and node overlay in Carpenter. So take it away, Jason.
Yeah, so the reason I haven't closed that original PR is because I think it really is more so on hold than in terms of we're rejecting the design. I think that probably will likely be where we come back to, but the hope, the concern with it in its current state from people like Alice was that the breadth of the API for an end user to configure is really large and really kind of confusing. I mean, of course, with as an end user using DRA, typically you are not the one creating and managing resource slices. That is something that is left to the drivers. And so the drivers get to take on that layer of complexity. And arguably, resource slices are probably the most complex part of DRA. So there's definitely some hesitation in putting that into Carpenter's API. The argument that I'm going to make is that we kind of need all of that complexity to be able to model the different like the different pieces of functionality that people are going to want out of DRA in Carpenter in like any arbitrary driver.
Yeah.
But the idea and the reason for holding off, at least for the time being and for initial support, is that we want to do some of the like pre-built-in drivers first, get an idea of how customers are actually using Carpenter with DRA with those drivers and use that as the source of data to see, okay, what configuration do we actually need to expose via node overlay? Do we need to expose the entire resource slice? Or based on the way that customers are actually using this, can we collapse the API down to something a lot simpler? That would, of course, be the hope. Um, I don't know if we're going to get there, which is why I feel like more than likely we'll probably still come back to the injected resource slices and some of the additional metadata that went along with that, like the topology bindings, stuff like that. But that's kind of the hope is to start with some of these pre-built support for specific DRA drivers, and then based on usage, expand out from there. So like an obvious first choice would probably be to add support for the NVIDIA driver. Unfortunately, that is something that would need to be done on a cloud provider basis, just because there's no common way to reason about instance types.
Yeah, I mean the clear sort of like use case for DRA would be the various ways you could use GB200 at scale or GB300 at scale. It's just that getting access to an environment where you can sort of play around with that is sort of like you need CERN level capital expenditure. But
Right.
that's an interesting practical use case where you start to see concrete implementations of core topological concepts that DRA is trying to expose. So you have um, at least three different topological boundaries with multiple GB200s. You have IMEX, you have NVLink, and you have InfiniBand. So that would just give you a nice combinatoric playground to see how do you do that with how where can an autoscaler be useful, um, and how would it actually actuate those kinds of scaling requirements. But
Yeah.
as I said, that's really really tricky just because you're not going to feasibly get access to a data center full of GB200s and like mix and match.
The one thing I will be interested to see is will customers that are using these GB200s, are they interested in doing reactive auto scaling like
Huh.
what Carpenter
Great,
has, or
great question. No, no, great
will,
question.
yeah. And that's where,
It's like, is it actually practical? Is someone willing to say, okay, I've got $10 billion in potential spend, just go ahead and programmatically spend it for me? And also, are any of the hyperscalers actually offering sufficient overhead for that kind of a use case where auto scaling it's more like open up a customer support issue scale. Like, how do you get, even if I needed another GP200 rack or two GB200 rack, that might be something that has to go through a bunch of manual approval layers just because it's so expensive. And I would imagine the hardware capacity is constrained worldwide for that kind of a thing. So,
Yeah, and I think this is kind of the general use case we built out the static node pool feature for was we have a bunch of these expensive GPU instances, whether they're GB200s or more conventional GPU instances.
yeah.
And I know I'm going to use them all in this cluster. We're probably paying for them using something like an ODCR or a capacity block. So just scale them all up and keep them in the cluster.
Yeah.
Um, so the nice thing is Carpenter with static node pools, Carpenter and DRA work today because the scheduling side of things is completely deferred to Kube Scheduler at that point. Carpenter is just naively bringing up the instances. So, yeah, I hope for the common case where customers do want to use things like GB200 with Carpenter, that more than likely is the route they're going. But of course, we still do want to have support for reactive autoscaling with DRA.
Yeah, but
Because
I actually think even just poking at that would be actually really beneficial and something, KubeCon EU is a few months away. Sorry, 2 months away. That would be, I think, a totally useful material announcement to say Carpenter, like if we could produce a use case where Carpenter works today with static node pools and DRA as is, that's that's definitely substantial, I think.
yeah, yeah, I don't think it would be too difficult to um, make that happen because, yeah, as I said, it should just work
Well,
because
that's the cluster autoscaler use case as well. So it just, I think the combination of Carpenter's core functionality with the promise of DRA suggests a lot of really interesting things, but it's super frontier and complex, and
yep.
it would be very easy to produce a sort of set of solutions that are years ahead of an actual use case.
Yeah, and I think that may be largely where we're heading with the reactive is, yeah, we're
Yeah.
putting building blocks in place for all of these different potential future DRA drivers, but with the current main use cases, which are these like multi-node TPU instances, GPU instances, more than likely you're doing a static scale up. But yeah, no, I think we would be able to get an example together of that working. KubeCon EU, yeah, that's March 23rd, I think.
Yeah.
Yeah, that would definitely be something we should be able to do. Maybe not with GB200s. I just don't know if I can get one. But
Yeah. But we
with,
can, yeah, I mean, A100, anything would be, you could
yeah,
substitute with the DRA drivers should work. They're going to work on any of those. And
yeah,
we have lots of experience on that. So if you need more resources.
yeah. Any of the more conventional GPU instances, I can definitely get my hands on. I just, I'd need to put in a request for GB200s.
Yeah, yeah, no,
So,
that makes, I'm sure I would
yeah,
too.
they don't let me just provision them ad hoc.
Cool. Yeah. I mean, that's just something to consider maybe in the next few weeks as you ramp back up. Um, I think that would be an appropriate sort of reclassifying of scope that we just want to sort of ensure some basic functionality. So for customers, I don't think there are very many. The GB200 case is different because DRA is required, and
Yeah.
you have compute domain, these new native resources that are DRA native that go along with it. But I think let's assume there's more than zero customers who are using A100, H100s, or other, if you want to call those commodity um, GPU platforms, and are standardizing to using DRA semantics. Just having that kind of a basic, um, if you can instruct using the static capacity feature, Carpenter, that like when you see this resource claim that that's always going to go to this pool, which can scale
Well,
horizontally.
so the thing with static capacity does not automatically scale.
I
Static,
see.
yeah, static capacity is not reactive in any way. It is you define a node pool, you define a set of replicas, and it just maintains that set of replicas.
I see. I see. I see. I see. Okay, got it. That makes sense. So it's just
So
it's a provisioner interface that is um, available for manual administration. So I can go in and
yeah. And you
got it.
still have the other features that Carpenter has outside of autoscaling. So things like node lifecycle management, drift, expiration, all of those different features still work. But yeah, there's no automated like horizontal scaling.
I see. Okay, got it. Makes sense. Well, that's probably worth. Uh, I would agree with you that should just work. I'm going to assume that if you have the GPU operator and the DRA driver installed, and eventually the GPU operator will include the DRA drivers, but that's not true yet. But if you have that, if that's your delivery mechanism for installing NVIDIA drivers and DRA drivers on your cluster,
Mhm.
as new nodes arrive, which Carpenter static capacity, if that actor is just building out new nodes, then the drivers should arrive on those nodes via the daemon set,
Yeah.
and the resource slices should just come up. So maybe that's worth just a afternoon exercise in the background confirming that there's no edge cases, but I would not expect there to be any edge cases with that. And you actually wouldn't want static capacity to do anything. Like you wouldn't want to bake in like some capability to install. I don't know how this works, but I assume that you would not want to install the GPU drivers and the DRA drivers via static capacity. You want the
No.
operators to do that for you.
No, yeah, and that's not what we do today either. Um, what you do have is like in ECAS auto mode, for example, our GPU AMIs do have those drivers pre-installed, but
Yeah,
that would all be part of like the AMI. So it would either be deferred to the AMI itself or to like custom installed daemon sets or any
yeah,
other
yeah, for sure.
drivers.
You guys are saying the static node pools work right now with Carpenter? Because that's not true, right? Like it
It,
would if you changed scheduler to take DRA pods.
well, so static provisioning. I want to be clear, static provisioning does a very basic thing. It's just
Yeah,
here's a node pool spec, scale up this number of nodes.
right.
It
So
completely
it's sort of like
bypasses the
cluster
scheduler.
API, Alima.
Hmm.
Yeah,
It's
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 basically
like having a kappa on the AWS side, like machine
yeah.
Hmm.
pool or machine deployment, and just update the replica count.
Yeah, it's basically we introduced it to address a use case where a lot of customers had both EKS managed node groups, which are just fixed sized node groups that are backed by AWS autoscaling groups. A lot of customers had a mix of those for any fixed capacity that they don't want to autoscale, and then also using Carpenter in the same cluster, but they wanted to use the same orchestrator for all of their capacity. So that's where static capacity comes in.
Yeah, but like you guys were saying that you guys like it would be good for KubeCon to kind of talk about static node pools working with DRA and Carpenter.
I was sort of mistaken about what static node pools actually or static
Yeah.
capacity actually did.
Okay. I see, I
That's
see.
in my mind, it is not a surprise that it works because we're just scaling up the nodes naively without any concept of the workloads that are scheduling to them.
Yeah, okay.
I think it's
So,
worth maybe having some best practices, like for GB200 in particular. Like uh, if a user were to naively sort of like um, scour the feature set of Carpenter and then compare that to the operational requirements of GB200, they might think, oh, I can't use this in my cluster because it doesn't do DRA, for example.
yeah.
But we could lay out a scenario where you can use Carpenter in your cluster. Either, I mean, Jason, is if you have your cluster, if Carpenter is enabled for your cluster, and you don't enable static capacity, do you run into race conditions where Carpenter starts reaping nodes that you don't want it to? So are you actually recommended for any nodes running in your cluster that you don't want to be actively consolidated by Carpenter to put those into a static capacity pool? Is that the best practice?
So you're saying like if you have any nodes that are not managed by Carpenter, would they be reaped?
Yeah. I mean, is there an
Yeah.
easy way to sort of like put nodes in a non-Carpenter, like Carpenter's like, don't pay attention to these. Some other
Yeah,
authority is
Carpenter
in charge. Yeah.
Carpenter
Okay.
annotates all nodes that it provisioned.
I
So
see.
Carpenter
Okay.
isn't going to manage like if there's not a node claim for a node, Carpenter is not going to mess with it.
Got
Uh,
it.
so yeah, you can use any other like node provisioner with Carpenter, whether that's like static node groups, manually like launching instances, registering them as worker nodes, another autoscaler like Cass, you can use it in parallel. Um,
Yeah, I don't know if it's worth I could think about this. I don't know if it's worth adding to like either the Carpenter just dev documentation under like an FAQ section. How do I use DRA with Carpenter? We could just be explicit that Carpenter doesn't currently support reactive scaling for um, DRA driver enabled nodes, but you can run DRA nodes on your Carpenter enabled cluster in this way, and you can just describe the couple of options.
yeah, I could see us adding it to, we have a growing section on our docs site called tasks, which is more so meant to be rather than like just straightforward documentation of this is the resource, this is what every field does. Like, okay, how do you achieve certain things inside of Carpenter? So basically, that use cases section, I could see it being something that we add there.
Yeah, cool. Does this make sense, Alima?
Yeah, it does, but I feel like already there's this idea of that more users need to adopt DRA before, like, is that clarification even that necessary?
I
Sorry,
think, go ahead, Jason.
a clarification for what, I guess. So the
Like
only thing we're thinking about data is for the node overlay integration. We're still moving ahead with the scheduler integration for reactive
Mhm.
autoscaling and extending the cloud provider interface such that different cloud provider implementations can describe which resource slices are available for a given instance type.
Yeah. Well, I was just saying the idea that having DRA enabled pods, like if it's able to be taken in by a cluster with that's Carpenter enabled, like I feel like that distinction isn't doesn't need to be made, right?
I think
I
you would
think
want to just potentially be super clear. I think it's easy for engineers working on Kubernetes
Okay.
to understand how, in the situation we're describing, DRA really has not, it's not intersecting with Carpenter at all, but just making that clear
Mhm.
for someone who'd be like, I'm running Carpenter on my cluster. Can I run, can I add a GB200 to my cluster? And just saying, yes, you can. Here's how you could do that.
yeah.
Like
Mhm.
making it clear that Carpenter won't
Yeah,
reactively, like I can't, for
I
example,
see.
in the
Like with
future, the idea
mhm.
would be that I've got a cluster, I've got Carpenter installed, and I um uh I don't know the exact way that this would happen, but for example, I express a workload in a compute domain compatible structure. So I basically say I here's a workload that requires a compute domain, and something like Carpenter will carry out end to end all of the necessary infrastructure outcomes to do work, which would include provisioning a GB200 from scratch, for example, or potentially in a future world where hyperscalers make GB200s like available sort of on demand. Like maybe I can get just like four racks from a GB200 instead of all 18 or whatever. You can imagine how that could be expressed as in terms of like provisioning. That could be expressed as in the DRA native language of the workload, and then Carpenter sees that and says,
Mhm.
"Oh, I need to go get four GB200 nodes. I need to make sure they're on the same IMEX channel, all that kind of carry out all that work, and then provision those as nodes in Kubernetes. But that's far in the future. But someone might be thinking that a user might think,
Mhm.
how do I add a GB200 to my cluster in terms of like, how do I tell Carpenter to add a GB200? And we should be clear, like, oh, you
Yeah.
can't do that.
Mhm.
Here are some ways you could add a GB200 to your cluster.
Mhm.
Yeah, and I think it is fair to say that like the layman using Kubernetes does not necessarily understand the distinction of the responsibilities of each of these separate components, whether it's Carpenter, Kube Scheduler, Kubelet, like what needs to support what with DRA for it to work. So I definitely think it would be non-obvious for a lot of users that,
Okay.
okay, Carpenter doesn't support DRA with reactive autoscaling, but it makes perfect sense that it supports it with non-reactive autoscaling. Because I do know a lot of people conflate like what Carpenter's responsibilities are and what the scheduler's responsibilities are. And a lot of people think Carpenter just supplants the scheduler when it does not,
Mhm.
which probably is not helped by the fact we talk about Carpenter scheduling nodes a lot, but just inside of a scheduling simulation.
Yeah. Just a quick sort of housekeeping question, Jason, is if so there was a big discussion at KubeCon, which we talked about, that the next time we have a discussion like that, you or someone, folks in Carpenter should be present. So
Mhm.
I'll definitely reach out to you. Is there anyone else that I should advocate that we invite sort of as a matter of routine going forward?
Probably reach out to Ellis.
Okay,
Uh,
cool. Is Ellis sort of back paying more attention these days?
Yeah, he is. He's been pretty active. Yeah, obviously I can't speak for him if he'd be available or anything, but he would be a good one to reach out to.
Okay, that's awesome.
Him and myself.
Cool. So it seems like next steps, so the PR, Alima, just remind me, that's the Quack
Mhm.
PR. Cool.
That's the
Great.
config. Yeah,
Mhm.
Great.
the
So you guys are
config
making
map
progress on
case.
that. That's awesome. And then we can sort of take stock next Thursday. Is next Thursday the day where we need to do it in the morning if we were to meet?
It might be.
It's not.
It's not. You're on top
Next
of it. All
week
right,
is
cool.
3 p.m. Wait,
Yep.
sorry, just to be clear, non-reactive autoscaling is static, is like when you have static capacity.
Yeah. So when I say
Okay,
non-reactive, I just mean
okay,
we're not reacting to pods in the cluster.
sure. Yeah. Okay.
So yeah, I was thinking, unless you guys have any objection, we may want to move this to a bi-weekly meeting. Um,
Yeah.
just because I don't think we typically have enough content for meeting weekly. Um, I'll take some responsibility there. I'm making slow but steady progress on the implementation PRs for the reactive scaling side of things. Um,
Yeah, it's all
Yeah,
good. I
the
mean,
worst I
as far as I'm concerned, canceling ad hoc is completely normal. So I'd be happy to, if we ended up meeting every month, just having something on the calendar to remind us um, is great. So,
yeah,
but I can also go to. I don't remember who created this calendar invite on behalf of the SIG, but I can go set it to biweekly.
yeah,
And
I
if I do
did.
that, I would. Oh, you did. Okay, cool.
Yeah,
So if you could, if we want to do that, then if you could set it up so we never have to worry about the 9 a.m. conflict, that would
yep,
probably be the most convenient.
yep. That's what I was planning.
Okay,
Um,
cool.
yeah, we can start with biweekly. Of course, if progress starts happening really quickly and we want to move it back to weekly, we can.
Yeah, awesome. And if it starts to get really interesting, I can always bring it to a agenda item for SIG Autoscaling and invite you. It's early, but it's not so early. It's 8 a.m. It's on Thursdays today.
Yeah,
I'm there every week, so
yeah,
Okay, that sounds
for
great.
sure.
Yeah, I definitely will ask ad hoc if needed.
Yeah. Unless there's anything else bookkeeping, I did think we could maybe discuss some of the higher level items with the Quack driver from my review.
Oh, sure. Yeah.
Yeah, so I'm not really referring to specific comments. Really more so, I think capabilities we want to be able to express with the Quack driver.
Sure.
Um, I think the one major thing is we're going to want to be able to express multiple drivers in the cluster simultaneously. Um, in particular, like one of the big use cases that we're looking to support is um, you have multiple different drivers, and you have a resource claim which has requests for devices from the same driver,
Hmm.
but they have bound attributes. So, like, let's say with a GPU and an EFA, I know there was a KubeCon talk given a little while back, I think in June, about this use case where you have a GPU and a NIC, and you want to make sure they're on the same PCIe route. That way, they don't need to go through the CPU. Now, uh, the DRA driver to provision EFA, or sorry, I keep saying EFA. That's AWS specific. I'll keep saying NIC. Um, the NIC and the GPU, those are going to be different drivers, but we need a way to express both of those drivers in the cluster simultaneously to be able to test that type of use case. So I think, and correct me if I'm wrong and I misunderstood anything, right now, the config just supports one driver at a time with multiple resource slices, right? I know it's been a while, so if you don't recall the context because it has been a while, no worries.
I don't recall, but I see no issue with having multiple drivers and then just having like all the resource claims like on the API server to be
Yeah.
picked up.
Yeah, so that was my
Is there
thought.
any issue with that? Okay, yeah.
Well, no, right now the config only allows you to express one driver name.
Oh, okay. Can I not just change that? Like, that doesn't seem like a hard fix, right?
Well, I think the way we probably want to express it is it's not just like we want to make it a slice of driver names. I think what we want to do is probably support multiple config maps, or since we're making it a strict type for the config, I
Okay,
think instead
yeah.
of a config map, we may as well make it a CRD. Obviously, this isn't going to be used in production for you to make breaking changes as need be, but just that way we get server-side validation of like the schema, and you don't have to do the in-process validation that you're doing
Okay.
today.
So we would have a config map for every driver.
Yeah, potentially multiple. Like
Yeah, okay.
I would say there are probably use cases where we might want to have multiple config maps for the same driver. Like, consider you have two different node pools, and each of them have different configurations for the same driver. So the resulting resource slices for the same instance types might look different across drivers.
Hmm.
That would be a scenario where we might want to have multiple config maps or multiple custom resources for the same driver, but applying to different nodes.
Hmm. Okay. Wait, I'm looking at it right now. Oh, like maybe I'm being naive, but in what if we just had one config map with for multiple drivers?
We could do that too. The one thing you might run into, depending on test scenarios, is like max set CD size. I
Okay,
don't know if
that
we're
makes
going to
sense.
actually run into that in practice, but for example, my understanding is that's the reason you can have multiple resource slices in a pool. Was the concern was if each driver only defined one resource slice, with the number of attributes you could potentially have, you could potentially run into scenarios where you hit the max set CD size for a single object.
There are also some artificial ceilings on some of the the sizes that
Okay.
they're grown to. But
Mhm.
Okay, that makes sense. This is better because then yeah, I agree with this. Um, Wait, to start, I'm gonna finish that, and then I feel like I'll make another design doc. And I don't know if a doc is necessary for this, but I feel like I'll first address your comments for this case where we have like just one driver per config map. Or yeah, we just have one config map, and then I can think more about having a CRD.
Okay, and for what it's worth, it doesn't need to be a CRD. It could just be multiple config maps. Um, the reason I'm thinking it might be easier just in general to do a CRD is because you're doing a bit of internal validation. And if we do it with a CRD, we'll get like the validation for, say, the resource slice schema for free, if we embed it into the CRD. Because rather than doing the validation as part of like the Go process, we
Hmm.
defer the validation to the API server.
Yeah. Okay. I agree. Also, you know how like the DRA example driver, like it onboards uh like third party device like to onboard onto the DRA example driver. Like I feel like it's better practice to do something where like let's say different device types come up, they can create their own driver and config map
Um,
instead of us manually doing it.
so I guess the use case I'm envisioning, I mean, for how we're going to use this with Quark, there will never be any real devices, right? They're just a series of like fake devices that we are defining for the sake of testing.
Yeah.
I guess which third party what would an example of a third party device be in this scenario?
Like for example, for the DRA example driver, you you have multiple like third party companies like onboarding to be a DRA driver for specifically their devices. So I'm thinking that it's the same, like even though we're testing specific device types, in the future, like there could be different devices. So then for that they would create their own DRA driver, and then they would also want to test with Quark in Carpenter. And then for that, like this config map case that we're testing wouldn't apply for those devices.
I guess I'm not really thinking about that as a potential use case. Maybe it would be.
I think
Um,
that's way far into the future, but I'm just saying that a CRD is better for that, right?
yeah, a CRD would be. The reason I think a CRD is probably better all around. Um, but the I don't imagine you're going to have very many devices trying to integrate with Carpenter and test the
Okay.
integration at the Quark level. I
Hmm.
imagine you'll be doing that at like the provider level.
Okay.
So you've already written the driver for your device and you want to do an end-to-end test of that device with Carpenter. You would want to
I
do
see.
that probably with real instances, real devices, like test the full end-to-end flow. I don't know if the value is there doing it with Quark for third-party
Okay.
companies. It could present itself, and I do agree it would be nice to be somewhat extendable to that, but
But
um,
I see what you're saying. It would already be there
yeah,
as a driver.
I view the purpose of this, at least for the time being, for us to be able to test the scheduling primitives rather than to necessarily test against realistic devices.
Hmm. Okay. Yeah, that makes sense.
Yeah, I think the other thing that was maybe a little bit less high level and more um, just another capability that would probably be good for us to have is the ability to test like more natural, I don't know what the best way to describe it is, but like pool cycling. Like when a DRA driver updates the advertised devices, it creates a new set of resource slices with a new pool generation, and then deletes the old resource slices. Us being able to simulate that behavior would also be valuable. Um,
Okay.
I don't think we're going to be able to aggressively test, or aggressively is the wrong word, consistently test some of the edge cases around that, like making sure we're handling incomplete pools, um, stuff like that through ET quant tests. We'll definitely have more concrete tests for that in unit tests, but if we're not handling those situations properly, you would expect if we have more realistic pool generation, those tests would flake and we would be able to get results that way. So I think there's probably still value in having that.
Okay. Mm,
That was, I think, all I had high level to discuss. Of course, if you have any questions on any of my comments, I'm free to discuss now and any other time. Um,
yeah.
as I said, I know I left the review 3 hours ago, so I was not expecting a full review.
Okay. Yeah, your two higher level suggestions make sense. Um, I'll leave a comment recapping that on the issue, or not the issue, the PR. Um,
Okay, sounds good.
and yeah, thanks so much. That all makes sense.
I guess anything else anyone wants to discuss, or do we want to give 20 minutes back?
I don't have anything. I'll probably just ping you if I have any questions on your comments,
All right,
like
sounds
separately.
good.
Yeah, I'm good. Thanks, folks.
Yeah,
Thanks.
thanks.
Happy
Bye-bye.
Thursday. Bye.
See you. Happy Thursday.